Hey everyone. So this is our first lecture for Chemistry Unit 2. And what we're going to be talking about today is scientific notation. So I want to tell you a little bit about what scientific notation is and why we use scientific notation. Basically, it's a shorter way for us to write very large numbers or very small numbers. It makes doing mathematical calculations or writing answers a little bit quicker and a little bit easier on us because you don't have to worry about so many zeros or so many decimal places or so many ones places or number places. So right here I have an example. This is 1,200,000, and I could write this shorter as 1.2 times 10 to the 6th. Right here, this is 0.00000000012. And to make it easier on me, I could just write 1.2 times 10 to the negative ninth. Now, this may seem like this is a whole lot more complicated, but it's really not. So what we're going to do is we're going to just kind of walk through how you do scientific notation now that we know why we do scientific notation. We're going to practice putting some numbers in it and taking some numbers out of it. And then we're going to practice using your calculator to punch in problems that utilize scientific notation. And then when you finish this, you'll be able to complete the scientific notation worksheets number 1 and number 2 in the Google Classroom and submit those. So what I want to do is I want to talk real quickly about format. So when we discuss format of scientific notation, there's a very specific way that I ask students to do their format. If you'll notice with both of these examples right here at the beginning, both of those have something in common. They have a digit, then a decimal, and then another digit, okay? All scientific notation problems have to have one digit and only one digit in front of the decimal. You can have as many as you need behind it, but in front of, you only have one. So if I were to write this as 12 times 10 to the 5th, that would not be correct because I have to say one digit in front of the decimal, so it's 1.2 times 10 to the 6th. Okay, right here, I could not say 0.12 times 10 to the negative 8 because I have to have one digit in front of the decimal. I say 1.2 times 10 to the negative 9. So that's the format. The format is you always have to have one digit in front of the decimal, and then you can have as many digits as you need behind the decimal, but this one is required. There is one and only one digit in front of the decimal. Okay, so let's talk about how we put numbers into scientific notation. So it's really kind of simple. So let's say that I get my paycheck this next week, and they've decided to give me a raise. And so my paycheck this month is going to be $3,527,000,000. And I'm going to take that paycheck and I'm going to run. So behind this number, there is an understood decimal, which of course you know that from math class. So what I'm going to do is I'm going to move that decimal all the way down my number until I get it right behind the first digit as required, okay? So now I have 3.527. I'm not going to worry about writing all those zeros there. I'm just going to drop those zeros, okay? So this is how I would write the decimal portion of this scientific notation. So anytime that you are dealing with a whole number, okay, when you write your scientific notation, your superscript or exponent is going to be positive. So it will be a positive exponent. Okay, so since this was a whole number, I know I'm going to have a positive exponent. Now, the way I know what my exponent is how many places I move my decimal. So I move my places 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 places. This was a whole number, so it becomes 3.527 times 10 to the 9th. Okay, so let's look at another one. Let's do this number, 4,720,000. Okay, you can pause it right now, and I want you to put this number in scientific notation, so pause. So when we put it in scientific notation, I'm going to move my decimal all the way to the right so that it's behind the first number. So I have 4.72. And I'm just going to drop those zeros, okay? So once again, I'm going to make sure I meet this format, which I do. And now I need to count how many times I've moved my decimals. So that's 1, 2, 3, 4, 5, 6. So that means I would write times 10 to the 6, and it is positive 6 because I began with a whole number, okay? So let's talk about what happens when we have a decimal number, okay? So let's say that after they give me this paycheck, the next month they realize they gave me too much, so they want to give me something. So my paycheck this month is going to be a fraction of a cent. It's going to be 0.0000003527. Okay, so once again, I'm going to put my pencil on that decimal place, and I'm going to move it all the way down and deposit it right behind the first digit so that I meet the requirements for format, which is a digit, decimal, and then the rest of the digits. So now when I write it, I'm going to write 3.527 times 10, and then I'm going to count how many places I moved it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8. And then because this is a decimal number, my exponent is now negative. So when I write it, I have to put a negative 8. Okay, you take a second and I want you to do this one, 0.00031. Pause it right now and do that one. So after you finish, you get 3.1 times 10, and you have to move it 1, 2, 3, 4, negative 4. And I know it's negative because I began with the decimal number, okay? So when you finish learning how, well, now that you've learned how to put them in scientific notation, let's talk about how we take them out, okay? So let's say that I give you the number 6.4 times 10 to the 8th, okay? Well, what I would do is I would immediately look at my exponent. And do you see how this is a positive? So I know that a positive exponent means this is going to be a whole number. So when I see a positive exponent, I know I have to move my decimal to the right. So I would say 6.4, and I would go 1, 2, 3, 4, 5, 6, 7, 8. And everywhere I have one of those little dips, I would drop in zeros. So it would be 6, 4, 1, 2, 3, 4, 5, 6, 7 zeros behind it. And so my answer is 640 million. Okay, so I want you to do this one, 7.3 times 10 to the 5th. Pause it right now and work that one out for me. So after you work that one, you get 73124. So your answer is 700 and, oh, I did that one wrong, sorry. 7.312345. I had it right. 730,000. Okay. So let's look at if it is the opposite. Let's say that I have 1.3 times 10 to the negative fifth. Now I see I have a negative, and we know negative means decimal number. So if we have a negative exponent, that means that we're going to move to the left. I guess the best way to draw that would be this way, to the left. So in this case, 1.3, I'm going to go 1, 2, 3, 4, 5, and drop my decimal. And everywhere that I put a dip, I drop in a 0, so it's 0.000013. I always ask students, or I always have students who ask, what about the 0? Do I have to put that there? I do that because I was just conditioned to do that by my teacher, because it keeps me from losing my decimal on the page. That is not a requirement. It just kind of helps you to be less likely to lose that decimal when you're working a problem. All right, so let's do this one. Let's do 4.07 times 10 to the negative third. So if you would pause it and work that one out. So you should have gotten 0.00407 because we move our decimal 1, 2, 3. So we have to put 2 zeros right there. Okay, so that is putting in and taking out a scientific notation. I do want to show you how you would do this on your calculator. So let's just say that I have a problem. Let's see, right in this. Well, let's just say that I'm given a problem of 1.4 times 10 to the 7th plus 6.3 times 10 to the 4th. Now you can work these out, and I know some of you have probably learned how to do mathematics with scientific notation, but we're learning how to do things quickly, so we bring in the calculator. Okay, you have to have a scientific calculator because you're looking for this button right here. It's going to say EE, or you may have one down here that says EXP. A few of you may have an EE button, but you have to hit second to get to it, okay? So you've got to find your EE. If you're not sure where yours is, you have a fantastic thing called Google. Google the model number and learn how to do it, or go to YouTube and look up a YouTube tutorial on how to put numbers in scientific notation. This is a TI-30XA from Texas Instruments. And so if you have one of those, there's your EE button right there. So when we punch this in, we say 1.4 EE 7. Now please notice, I did not type in times 10. Do not type in times 10. The EE button takes the place of times 10. If you say 1.4 times 10 EE 7, your number is going to be off. Okay, so you only put in 1.4 EE 7. Then I'm going to say plus 6.3 EE 4 and hit equal. And this is my answer. Now, if I wanted to know what that was in scientific notation, because more than likely that's what it would say on the test, I can hit second, psi, and there is my answer, 1.4063 times 10 to the 7th, okay? So this is how you would punch it in the calculator. So you say 1.4 EE 7 plus 6.3 EE 4. And there's your answer. Now you could put it in scientific notation if you wanted to, or you could say second, psi, and there's your answer. Okay? So I hope this helps you. If you have any questions, feel free to message me or email me, and I'll be glad to help you out.